Chemical Equilibrium Part 4, KEQ for homogeneous and heterogeneous equilibrium reactions. A homogeneous equilibrium is one where all reactants and products are in the same phase. Usually we see that all of the chemicals in the reaction are aqueous or all of the chemicals in the reaction are gas. A heterogeneous equilibrium is one where reactants and products are in two or more phases. Remember that pure solids, pure liquids, and solvents are not included in the KEQ expression. So a quick review: if we have A moles of chemical A reacting with B moles of chemical B in equilibrium with D moles of chemical D and E moles of chemical E, the equilibrium expression Kc, in other words KEQ expressed with concentrations, is equal to the concentration of chemical D multiplied by the concentration of chemical E, the products, raised to the power of their respective stoichiometric coefficients, divided by the concentration of chemical A multiplied by the concentration of chemical B raised to the power of their respective stoichiometric coefficients. So, the product of the concentration of the product chemicals raised to the power of their stoichiometric coefficients divided by the product of the concentration of the reactant chemicals raised to the power of their stoichiometric coefficients. Now, if we want to express KEQ with pressures, or Kp, we just use partial pressures for each one of the chemicals instead of concentrations. Once again, omit pure solids, pure liquids, and solvents from the Kc or Kp expressions. So let's take a look at some examples. In this first example, we have all chemicals that are aqueous. Well, that means that this equilibrium would be homogeneous, since all of the chemicals are in the same phase. They're all aqueous. So the Kc for this expression, the equilibrium constant expressed with concentration, would be the concentration of this product divided by the concentration of this reactant divided by the concentration of this reactant raised to the second power, because we have a coefficient here of 2. Now you might say, well, what about these coefficients? That's 1 and 1. Well, we typically don't put powers of 1 in the Kc expression. So you could put a 1 there, and you could put a 1 there if you like for powers, but you don't have to do that. All right, here's another homogeneous reaction where everything's aqueous and it's balanced with all coefficients of 1. So the Kc expression would look like this. Product divided by reactant concentrations, each raised to the first power, because each stoichiometric coefficient here is 1. Here we have a reaction where almost everything's aqueous, but then we have this liquid water at the end. Remember that liquids are not included in the KEQ expression. Whether you look at that as a solvent or just a pure liquid, liquids are not included here. So the Kc for this reaction would be the concentration of this product to the second power, because of that 2 coefficient, multiplied by the concentration of this product to the first power, because of that 1 coefficient, divided by the concentration of this reactant raised to the first power, because of that 1 coefficient, and the concentration of this reactant raised to the 1 power because of that 1 coefficient, and the concentration of this product, or I'm sorry, this reactant, raised to the third power because of the 3 coefficient. So the product of the concentrations of the products raised to their respective stoichiometric powers divided by the product of the concentration of the reactants raised to their respective stoichiometric powers. And here we see another reaction, but in this case we have the liquid on the reactant side. So now it gets omitted from the bottom of the expression. Again, any pure liquid or pure solid or solvent is omitted from the KEQ expression. Some more examples of Kp and Kc, and now we can use Kp since we have reactions that are involving all gases. So here we have a gas and a gas and a gas. We could say that the equilibrium constant, or Kp, is equal to the partial pressure of this chemical multiplied by the partial pressure of that chemical, each to the first power, because we have one coefficients, divided by the partial pressure of this chemical raised to the first power, again because of the one coefficient. If you want to express that as Kc, we just use concentrations. Here's another reaction with gases. 3 oxygen molecules, O2, is in equilibrium with 2 ozone molecules, O3. So because they're both gases, we could say Kp, the equilibrium constant expressed with pressure, is equal to the partial pressure of O3, this product, raised to the second power because of the 2 coefficient, divided by the partial pressure of O2, this reactant, raised to the third power because of that coefficient. And here would be the same expression, but now we have concentrations instead of pressures. And then take a look at this reaction, again with all gases. And notice that in this reaction we actually have gaseous water. Now, solids and liquids and solvents are omitted from KEQ, but since this water is a gas, it's included in the KEQ expression, both with Kp involving pressures and Kc involving concentrations. So the pressure of this product to the third power multiplied by the pressure of this product to the fourth power divided by the pressure of this product or this reactant to the first power and this reactant to the fifth power would be the Kp, and here it is with concentrations. Some more examples of Kc and Kp. Here we have a solid reactant and 2 aqueous products. So Kc would be calculated using only the concentration of the aqueous products raised to their stoichiometric coefficient powers. So here we have a 2 coefficient, so that's second power, and here we have a 1 coefficient, so that's first power. Here we have a solid and a gas and a solid, so both solids would be omitted from the expression and only the gas would be included in the expression. So Kc would be 1 because there's nothing to add in there for the products, which are in the numerator, since we omit the solid. And we omit this solid in the denominator, but we include that gas, so the concentration of CO2 would be the only part or the only chemical that's involved in calculating Kc and Kp. Pressure with Kp. Notice we have a solid and a gas, so these 2 gases would be in the KEQ expression. Here it is with concentrations, and here it is with pressures. Notice that because we have a 2 coefficient for the S, it's the concentration squared for S, and the partial pressure of S squared as well. Since we have a 1 coefficient for CS2, it's a 1 coefficient with both concentration and pressure in the numerator. Expressed with concentrations and expressed with pressures, we omit solids or liquids or pure solvents. Here we have liquid bromine producing gaseous bromine. The liquid's omitted from the Kc and the Kp. And remember that we always will omit pure solids, pure liquids, and solvents. They are not included in any KEQ.